Hi, Ryan here again. We're going to go through number 15, complete the following diagram by filling in the boxes. So let's go to number 15 and boom. This looks like a big confusing problem. It looks like something you've never seen before. This was actually in my exam when I took it last year, but it's actually very similar to what you have seen. It's just another free radical substitution reaction, just like the ones that you've seen before. It just looks a bit different. So it looks like a bear, but we're going to work through it simply and show how you could work through this when you see a problem like this on your exam, because I bet you will. So first we see there's the homolytic cleavage of this molecule, right? And we're asked to fill in the diagrams for A, B, C, D. And when we're trying to figure out what A is, we know that A plus, let's label this X, A plus X yields this molecule, right? Because this molecule right here is breaking apart to create this and A. So if we created this, what happened? What's A? What happened to get us there? So let's take a look at our homolytic cleavage reaction. If what we created was a molecule of this with one free radical, what was left over? Well, just these, right? Because we created two of these molecules, and that means we have left over the nitrogen in the middle. But before we just assume that, let's look at how that reaction happened, okay? So there was homolytic cleavage of this bond. So we're going to say that one electron moved to this carbon, and then one electron moved into this bond. And likewise on the other side, one electron moved into the bond and one into the carbon. And if we're adding two more electrons to this nitrogen, we're able to make N2. So that's what we're going to fill in for A, N2. We just made a nitrogen atom, and that was it. Okay, let's get rid of this clutter real quick. Now we're asked to figure out the reaction between this molecule and this molecule. And again, it looks very complex, but we got to figure out, what's our end product? What did we end up with? And so we see we made this. So again, free radical step. This molecule lost its H. That H is there no longer. What happened to produce that? Well, just another free radical propagation step. So one electron from this bond came and formed with this free radical, and then the other electron went into that atom. So what are we left with? NC, C with the two methyls, and then the H, because we could see, getting rid of this clutter, that this molecule just stole the H from that. And we see that left over here. There's no H. So the H went right here. Moving on to the next step, we have this as our free radical. So another propagation step. What happens? Well, our end product is this, and we see that this molecule no longer has the bromine that it originally had, meaning that this molecule right here stole the bromine. Let's show the reaction for it. So that's what happened. We see the movement of electrons, right? I'm denotating these by hooked arrows. They're not double arrows. They're hooked because it's the movement of one electron. So this electron and one of the electrons from this bond came and formed together to bond bromine to this atom right here, leaving this atom as a free radical. So what's our molecule that goes into addition of this one right here? C4H9SN with a bromine now, and then another C4H9, C4H9. not enough space to write it. And then we see that this molecule right here, this one cyclizes, it forms a ring, a cyclic ring. And let's look at the reaction of how that happened, okay? So this electron right here, it wanted to steal an electron from this double bond, leaving just one electron at the tip. And when these molecules come together, this molecule, this carbon is being bonded to that carbon, so it forms a 1, 2, 3, 4, 5-membered ring. Get rid of this clutter again, which is what we see right here, a 5-membered ring. This carbon right here corresponds to this carbon now, that is a free radical. Moving over. This is where we'll initiate our free radical step, and we see that the final reaction between this molecule and this molecule leaves this and D. So we see that this molecule just stole this H to form that, okay? Getting rid of the clutter once again. We see that those come together, it steals the H, puts the lone pair electron on that SN molecule, creating CH3 because it stole the hydrogen atom. Okay, we got through that. Not so bad, right? Second part, predict the major organic product from the following reaction based upon the preceding mechanism. Okay, well, this molecule looks a lot like this one, right? Except this molecule, we could see it has 1, 2, 3, 4, 5, 6 carbons. This one has 1, 2, 3, 4, 5, 6, 7 carbons, okay? So what's going to happen? This one had 6 carbons, and it formed a 5-membered ring. This one has 7 carbons, it'll form a 6-membered ring. So just a cyclohexane with the methyl on top. And we don't need to write out the entire reaction because this one is just very similar. If we had our free radical right here, it would form a bond like this, right? So this molecule and this molecule are forming together, making a cyclohexane with this as the methyl on top. And then we could see which term best describes the conversion of 6-bromo-1-hexene to compound D. So this is our 6-bromo-1-hexene right here. And we see that the bromine was substituted for an H. This is a substitution reaction. Thanks for watching.